Good afternoon, sir.
Good afternoon.
Good afternoon, sir.
Good afternoon.
Good afternoon,
Good
sir.
afternoon, sir.
Good afternoon, sir.
Good afternoon, everyone.
Good afternoon, sir.
Good afternoon. Manpreet, are you here?
Yes, sir.
So, am I audible properly?
Yes, sir.
So, okay, students. So, in last two lectures, so we were working on infinite series. So, our goal was if summation an is there, then what is sum of this series? But then we have seen there are some cases where it is not possible to find exact sum. So then we made one compromise. So can we check whether the sum, whether the series can be replaced by a single finite quantity? So initially we are interested in its sum, but then if it is not possible to find sum, then the next point was, can we check whether the series summation an can be replaced by a single finite quantity, or in other words, we can say this summation an and from some given number to infinity is convergent or not. So that is our main motive. So now we will not discuss what is sum of this series, because that sum can be evaluated only if Sn is in compact form. If Sn is not giving any compact form like summation 1 by n or summation 1 by n square, then we have to go for some other techniques. So which is not a very simple technique. But in this course, we are going to study. So can we check whether this series is possessing any finite sum or not? So this phenomena is called convergence or divergence phenomena of infinite series. So no doubt the first one is use limit n approaches to infinity Sn equal to L technique. If you can find this term, so that is the best one. That is giving you the sum of this series. The second was if you can show limit n approaches to infinity an, so it is not equal to 0. That is Nstrom test. So we have discussed it in last lecture. So then we say this series is divergent. Now what is the next topic? So what should be the nature now? If it Sn equal to L is not possible, limit an approaches to infinity, an is not equal to 0, like in summation 1 by n or summation 1 by n square, or it is n plus 1 divided by n square plus 1. So can we say this series is convergent or this series is divergent? So how should we go for these type of series? So then the debate was there, which discussion mathematicians में रहा होगा. So then they tried to link summation with the integral, because if we see integral is somewhere linked with summation. So can we directly link this infinite series with summation, or there are some constraints? So in that direction, so one result is there. That result is in the form of integral test. So what is this integral test? Our main objective of this lecture. So that is integral test. So what is integral test? So let an be any sequence of positive terms and let an is equal to fn. where now what is meaning of this an equal to fn? An is in terms of n. Now we want to give some functional loop to that an. Means if like our summation a 1 by n is there, so then what is fn? So fn is 1 by n. So what is functional loop of this sequence? It is 1 by x. So it is 1 by n square. So what is functional loop of this sequence? It is 1 by x square. The only difference is in 1 by n, it is just like a discrete function. It is defined for n 1, 2, 3. And when we are calling 1 by x or 1 by x square, so we can explore it on the continuous range also. So let an be any sequence of positive terms. That means the first constraint is there. Now an is not any sequence. This sequence is of positive terms. So an need to be positive. So I'm here highlighting the constraints. So if an is greater than equal to 0, an is equal to fn. So where? Number one, fx is non-increasing. So non-increasing means, so it is decreasing or less than equal to. So that means an plus 1. So an plus 1. So it is less than equal to an. So it is for fx. So fx means for the continuous range. And then an plus 1 means for specifically an plus 1 less than equal to a. So there are two conditions. So first condition is it should be a positive terms. Then fx is non-decreasing terms. And then fx is continuous also. As so you can see as 1 by n. So 1 by n means n is running from 1, 2, 3, 4, 5. So we cannot claim its continuity. That is 1 by n, it is continuous 1, 2, 3 because it is defined in the discrete range. But when I'm saying 1 by x, so then 1 by x graph, so then we can discuss, yes, it is continuous from 1 to infinity on this side, open interval infinity. So for x greater than 1, it is continuous. So fx should be continuous. Fx is non-decreasing. Then the series summation n from 1 to infinity. So by default, I'm taking this series to be 1 from 1 to infinity. Otherwise, it depends upon n naught. Whatever number is there, so you can start from that number. So then the series summation n from 1 to infinity and the integral fx dx from 1 to infinity converge or diverge together. So let me first clarify this statement. So what is meaning of this statement? So there is one series summation an. So this an you can take like 1 by n or 1 by n square. So for a functional loop, you can take fx to be 1 by x or fx to be 1 by x square. Corresponding to 1 by n simply and replace n by x. Now what this result is saying, if number one an is positive, an is greater than 0. Number two, an plus 1, it is less than or equal to an. So first condition is for positiveness, second condition is for decreasingness, and third is so we cannot say that an should be continuous because an itself says 1, 2, 3. So an को functional look दिया आपने fx. So then fx is continuous. And what is fx? So fx is over ax. So fx is continuous for all n greater than equal to 1. So by default, I am taking 1, but it will be that number. It can be generalized to any number. So from where you are starting this series. So if it is 2, then it becomes 2. If it is 3, then it becomes 3. And if you want more clarity, you can replace it by n naught, then n naught, and then. But in most of the cases, it is 1. So I'm taking it to be 1. So then what this result says, then behavior of summation an and integral fx dx is same. Means this summation an, it will be convergent if you are getting a finite value of this integral. if the series is divergent, then you are going to get an infinite value of this integral. Means to judge behavior of 1 by n from 1 by x or 1 by n scale from 1 by x scale. So that is the main goal of this integral test. So I'm taking small proof for this result. So an, it is fn, and I'm talking about fx. So on this side, you can take x. This place is for 1, it is for 2, then 3, somewhere n, and then n plus 1. We are taking this sequence to be of decreasing nature, so it is of this type. Now at 1, at 2, 3, this n, and then this n plus 1. Now at n equal to 1, for n equal to 1, so an is a1 or fx is f1. So both are same. So whether I'm writing a1 or I'm writing f1, so both are with the same meaning. So at 1, so this value is this whole height. So this height is given by f of 1, and f of 1 is nothing but a1. So this fx or ax, so same meaning, f and a. So this one, it is a1. For 2, it is a2. For 3, it is a3, and for n, it is a. So whole proof is just to consider this graph in two ways. एक ही ग्राफ की दो इंटरप्रिटेशन है, and from those two interpretations you can find this proof. Now at a1, I'm just extending this rectangle, making this rectangle, making this rectangle. Now just focus on this area from 1 to this n plus 1, 1 to n plus 1. This area. Now, do we have any formula in integration to find this area? So we know what is geometrical interpretation of fx dx from a to b if fx is continuous above x-axis. So it gives area bounded by the curve fx x-axis between a to b. So same is case of this integral. So if we take 1 to n plus 1, so this area is given by integration 1 to n plus 1, integration 1 to n plus 1 fx dx. So I've shown some yellow area. So this yellow area, it corresponds to this integral. This whole area can be given by this integral. Now just see what is area of this rectangle. So height of this rectangle, so it is a1, because at 1 value of function fx, it is f1, and f1 is nothing but over a1. And this width, so it is 1, so a1 into 1, length into breadth. So area of this rectangle, so it is a1. Same is area of next rectangle, so it is a2, and then area of this nth rectangle, n, so it is an. Then again difference is 1 unit. So area of this first rectangle a1, area of second rectangle a2, this it is an. Now the point is, I want to compare this integral 1 to n plus 1 fx dx. For proof is just based upon these two inequalities. On one side it is 1 to n plus 1 fx dx, and on the other side it is a1 plus a2 and then up to an. So remember, a1 is there, a2 is, or an ye wala. Now can anyone suggest what should be this, what should be sign here? It should be less than equal to, greater than equal to, or exactly equal to?
Less than equal.
Less than equal
Less
to.
than equal.
Less than equal to.
Please, please.
Less than equals to.
ठीक है. So I request whenever first student is giving answer, just wait for me, only then start your chain. So 1 to n plus 1 fx dx. So be the first. जो भी first answer देगा उसके बाद मेरी please wait कर लिया करो. So 1 to n plus 1 fx dx. So it is going to be less than equal to a1 plus a2 up to an. Now the second interpretation. So I'm calling this inequality 1. Now just see. I'm taking same area. Means same graph. Not the same area. So it is 1, it is 2, 3, and then it is n or n plus 1. But now I'm making a rectangle backside. So it is 1. So 1 towards this side. बिल्कुल same height पे आपने 1 unit back किया. So it is not linked with the graph. It is just linked with this height. So it is 1. So it is a1. This 2, it was a2. So इसको ऐसे लिंक किया हमने. And it is a3 और यहाँ पे हमने क्या किया, यहाँ पे n. तो इस साइड पे हमने जो है इसको पीछे हमने एक एक स्टेप कर दिया. Now just focus on areas below these rectangles. Now integral is 1 to n fx dx. So 1 to n dx means area of this region. So I want to compare it with these yellow rectangles. So from where should I start? So we should not start from a1 because I'm taking 1 to n. So 1 to n below this 1 to n. So it is starting from a2. So I'm writing here a2 because this area, so it corresponds to this height. So it is a2. This area corresponds to this height. So it is a3, and the last area corresponds to an. Now can anyone tell so whether it is going to be less than or greater than rectangle?
Greater than.
Greater than equal to.
Good. So it is greater than. Now this a1. So this term was defined. हमें नहीं पता n before n equal to 1 क्या है. But for n equal to 1, this function was defined. That means a1 is defined. So a1 defined है. So I can add a1 to both sides. कोई problem नहीं होगा.
Sir,
प्लीज 2 मिनट अभी बीच में डिस्कशन शुरू करो. कोई ऐसा पॉइंट नहीं है जो मैंने मतलब गलत किया है. आई थिंक सब कुछ क्लियर हो जाएगा. मैं पूरा टाइम दूंगा आपको फॉर 1-2 मिनट. लेट मी कंपाइल. सो इट इज 1 to n plus 1, 1 to n plus 1, and then I've compared this area, this continuous area, with the areas of rectangles. Now the same rectangles, लेकिन थोड़ा इस साइड को हमने लिया 1 to n. So not taken a1 for the comparison. So a1 is a defined term. I've just added to both sides. So it is 1, and just rearranging this inequality again. So it is giving a1 plus a2 and then up to an, and then it is less than equal to a1 plus 1 to n. Just note down your points. मैं एक बार time दूंगा आपको for 5 minutes. Then you can ask. So it is fx dx. Now if I take this inequality 1 and 2, inequality 1 and 2, and just rearrange this inequality. So I'm getting 1 to n plus 1 fx dx. So it is less than equal to a1 plus a2 and then up to an, and it is less than equal to a1 plus 1 to n, and then it is fx dx. Now, if we see this middle term, this a1 up to an, so this term is over Sn. So this Sn is being sandwiched between these two limits. So if I take this term to be Sn, so it is less than equal to a1 plus 1 to n, and then it is fx dx, and then it is 1 to n plus 1, and then it is fx dx. Now convergence or divergence of series, that depends upon limit n approaches to infinity Sn. Now if I take n approaches to infinity, so this middle term, limit n approaches to infinity Sn, so that is going to decide over convergence or divergence of the series. Now what is our claim? Our claim is whatever is behavior of series summation an, same is going to be the behavior of integral fx dx from n1 to infinity, or जो भी range है 1 to infinity. Now the point is, if as n approaches to infinity, integral fx dx does not converge or it is divergent. If as n approaches to infinity, our integral is divergent. So we were taking from positive sides only, so it is going to be positive only. Now if as n approaches to infinity, fx dx is divergent, that means this integral, this 1 to infinity, so this integral 1 to infinity fx dx, so it is not defined. So when there are only आपने starting में claim किया है a1 plus a2, all these are positive terms. So sum of positive cannot be negative. So all these are positive terms. So that means this sum is divergent only because of one case. That means this integral is having infinite value. If this integral is having infinite value, now see, this sum Sn is there. Sn is less than equal to a1 plus 1 to infinity fx dx. When n is approaching towards infinity, so this term, this I'm calling it 1, I'm calling it 2, and I'm calling it 3. So when n is approaching towards infinity, and integral 1 to infinity fx is divergent, that means this term, so it is not a finite term, it is infinite term, and this sum limit n approaches to infinity Sn, so it is less than equal to some infinite term. But it can be possibility that any sum, so this sum Sn is sum of a1 plus a2, sum of positive terms. So this sum is positive, and any positive term can be less than infinity. So there is no harm, there is no you can say any exceptional behavior in this point. Any sum is less than infinity. But if we see its left hand side and we apply this logic on this term, so as n approaches to infinity, n plus 1 is approaching towards infinity, and 1 to infinity fx dx, this integral is divergent. So that means this number is infinity. That means this number is not defined. Now a number is Sn. We want to discuss its limit. Limit n approaches to infinity Sn, and this Sn, this side, it is a divergent number, infinite number. So at this infinite number, it is less than equal to this. So now what can be predicted about this Sn? So can we say this Sn is going to be finite now? एक पॉजिटिव सम जो है एक इन्फिनिटी से बड़ा है, एक इन्फिनिटी से ज्यादा है. Infinity is lesser than that limit. So that means this limit is not going to be finite, and so that means so limit n approaches to infinity Sn. So it is not going to exist, or it is approaching towards infinity, or that means this sequence is done. Now, if on the other side, if we take 1 to infinity, this fx dx to be convergent, if we take what is meaning of convergence of an integral, so convergence of integral means this integral is finite, so it is having single finite value. So now this integral is finite. Now just again just focus on this inequality. अब आपको लेफ्ट से नहीं आपको राइट से आंसर मिलेगा. Now this number is finite, so finite is less than equal to Sn. So finite is less than equal to Sn, so finite could be less than infinity, so कोई फायदा नहीं हुआ. But if we use this second inequality, this side, now you can see if this number is finite, a1 was already finite, so इसका meaning होगा as n approaches to infinity, this limit is less than some finite number, or that means this sum is going to be convergent. So when 1 to infinity, this convergent, so which implies this integral limit n approaches to infinity Sn, so it is also going to be a finite number. So in for both the cases, its behavior is judged by the convergence or divergence of x. So मैं 2 मिनट में एक बार explain करता हूँ, फिर then you can ask any question. So in series is summation an. So summation an, you can take an equal to 1 by n or 1 by n square. So I'm frequently using an or fx. वैसे मेरा n और x एक जैसा होता है, but differentiate please it. So it is fx. So an is 1 by n. So it's corresponding fx. So it is 1 by x. So had it been 1 by n square, fx would have been 1 by x square. Now, what is this integral test? This integral test says ये जो an है, it should be positive. Means series is series of positive terms. When series is series of positive terms, तो इसमें negative कभी नहीं होगा. That means sum is infinity only. So threat is only from one side. Only one type of divergence is there, and that divergence is that sum is not finite, sum is infinite. कोई दो limits वाला नहीं होगा, because it is sum of positive terms. The next is it should be decreasing. And the third function should be continuous. So that continuity, now you can see कि why positiveness was required, कि minus infinity वाला कोई issue नहीं है, an plus 1 less than equal to 1 for decreasing function है, and why this continuity is required, so that there is no threat to existence of this integral. This integral is existing from 1 to infinity. If these three conditions are satisfied, so then we can claim convergence of summation an on the basis of integral 1 to infinity fx. मैंने 1 लिया है, but even if it is n naught, कोई भी n naught है, so now you can draw your graph from n naught to this, and then you can extend it towards left or right, and your results are not affected. So जो भी नंबर आपके पास जहां से सीरीज स्टार्ट हुआ है, so you can integrate your function from that. Yes, please. I'm just giving you, क्योंकि मुझे क्वेश्चन करना है, 2-3 मिनट्स दे रहा हूँ मैं. You can ask any question.
सर जो आपने पहले fn is equal to 1 by n लिया था वो नहीं समझ में आया, वो क्यों लिया था और क्या मतलब था उसका?
ठीक है. Any other?
सर वो पहले बताना जी है ना, जो इंटीग्रेशन 1 to n plus 1 fx dx था,
हाँ जी.
सर उसमें पहले a1 क्यों नहीं ऐड किया?
सेकंड वाले में.
हाँ जी सर.
सेकंड वाला में
सेकंड वाले में. Bro.
फाइनल रिजल्ट लिखते ना सर एक बार।
एक जैसा फर्स्ट वाला ग्राफ है उसमें सर आपने एक 1 से छोड़ दिया, जो सर सेकंड वाला ग्राफ है उसमें आपने शुरू से किया है, वो नहीं समझ, वो एक बार बता दो.
देखो, आई थिंक दोनों क्वेश्चन जो आपको सेम ही क्वेश्चन में मिल जाने हैं. देखो, अगर मेरे पास सीरीज हुई 1 by n, ठीक है, तो इसका बिहेवियर किससे जज होगा? प्लीज रिस्पॉन्ड. इफ योर सीरीज इज समेशन 1 by n, तो मेरा इंटीग्रेशन क्या होने वाला है?
log n.
log n.
कहाँ पे पूछ रहे हो यार आप? मैं तो पूछ रहा हूँ कि फंक्शन का जिसका इंटीग्रेशन होगा वो फंक्शन क्या होगा?
1 by n.
1 by n.
1 by n. ठीक है. तो पहले ये सुन लो, सोच लो, n और x क्यों लिखते हैं हम? जब आप, मैं पहले भी क्लियर किया आपको, जब n लिखते हो ना, तो आपका फंक्शन ऐसे बिहेव करता है 1, 1 by 2, 1 by 3. अगर मैं x नहीं लिखता तो मैं इस फंक्शन को कॉन्टिन्यूस रेंज में नहीं ले सकता. आपके सिर्फ डॉट्स आती है ऐसे 1, 2, ये डिक्रीजिंग की सिर्फ डॉट्स हो सकते हैं डिस्क्रीट फंक्शन में. सो द फन ऑफ राइटिंग fx इक्वल टू 1 by x इज, जो आपने 1x लिया है, कि आपने कॉन्टिन्यूस रेंज की तरह फंक्शन की तरह सोचना शुरू कर दिया है. सो विच इज डिफाइंड फ्रॉम 1 to infinity. अगर आप fn लेते हो तो आपके पास सिर्फ ये डॉट्स आती हैं. तो पहले तो ये क्लियर होगा कि fx को 1 by x क्यों लिया है, क्योंकि अल्टीमेटली आपको इंटीग्रेट 1 by x को करना है. ठीक है. अब सोचो कि अगर मैंने फंक्शन लिया होता 1 by n, ठीक है, तो जो 1 by n है ये फंक्शन स्टार्ट कहाँ से हुआ? 1 to 1 से. अगर फंक्शन 1 से ना, तो अगर मैं 1 से स्टार्ट करता हूँ तो मुझे 1 से, मतलब जो जहाँ से स्टार्ट होगा मेरे को उसी से लेना होगा. तो जो फर्स्ट क्वेश्चन है, जो फर्स्ट ग्राफ है, उसमें कुछ प्रॉब्लम नहीं रही मुझे. सो 1 से शुरू होगा मेरा, 1 then 2 and then 3 और then 8. लेकिन अगर यहाँ पे लाते हैं हम इस क्वेश्चन में, तो जो आपका जो पीछे वाला ग्राफ है वो कहाँ पे जा रहा है? वो एक पीछे जा रहा है यहाँ पे. तो पीछे जा रहा है, इसका मतलब वो 0 पे जा रहा है. लेकिन 0 पे वो जो फंक्शन डिफाइन नहीं है. लेकिन अगर आप यहाँ पे सोचो तो मैं फंक्शन की हेल्प नहीं ले रहा हूँ. ठीक है. अगर इसको आप a1 को नहीं लेते हो तो इसमें कहाँ से लेना शुरू करोगे आप मुझे बताओ?
1 से.
आप 1 से लोगे ना. आप रेंज को करोगे कैसे डिसाइड इसको? आप 1 to n ही जा सकते हो, बिकॉज योर फंक्शन इज डिफाइंड फ्रॉम 1. आप 0 थोड़ी ले सकते हो पीछे इसको कि 0 पे ले जाओगे. योर फंक्शन इज डिफाइंड फ्रॉम 1 to n, बट जैसे 1 by n है, इट इज डिफाइंड फ्रॉम 1 to n. तो 1 से बाद वाला मिल गया, लेकिन 1 by 1 भी तो डिफाइन है. अगर पीछे एक्सटेंड कर भी दिया तो कोई इशू नहीं है. मैंने ग्राफ को नहीं लिया, ग्राफ को यू कैन रिमूव, ग्राफ नहीं है सपोज यहाँ पे, लेकिन इसको लेने में तो कोई प्रॉब्लम नहीं है. तो इसलिए जो है अगर ऐसा एरिया लेना है मुझे तो ऐसा एरिया मेरे को 1 से स्टार्ट करना होगा। लेकिन जब मैं इसको 1 से स्टार्ट करता हूँ तो मेरे पास जो रेक्टेंगल कंपैरिजन के लिए आता है वो फर्स्ट ये वाला आता है, फिर ये वाला आता है, फिर ये वाला आता है। तो ये A2 से ही शुरू हो रहा है।
सर इसमें एक डाउट है कि सर आप जैसे एस एन ग्रेटर देन एफ एक्स डी एक्स बोल रहे हो एक जगह और दूसरी जगह बोल रहे हो कि सर वो एफ एक्स डी एक्स ग्रेटर देन एस एन है, तो वो कॉन्ट्राडिक्ट नहीं हो रहा सर वो?
कहाँ पे कॉन्ट्रडिक्ट हो रहा है आपका जो? तो इसी उसमें तो फलाना है ना क्वेश्चन को। आपको जो है इस एरिया बाउंडेड बाय ए कर्व है, ठीक है, उस कर्व को आपने A1 प्लस A2 अप टू AN में आपने उसको मर्ज करना है। तो आपके पास जो ये इनइक्वालिटी आई है, अल्टीमेटली जो हम यही कहना चाह रहे हैं ना कि इसका जो बिहेवियर है कुछ ना कुछ उसके जैसा ही होगा। तो कहीं ना कहीं बीच में सैंडविच हो रहा है। तो 1 to n plus 1 fx dx, so it is being sandwiched between these two terms, A1 plus 1 to n fx dx। तो अगर आप लगाते हो कि अगर आप n इन्फिनिटी लेते हो और ये इंटेग्रल डाइवर्जेंट है, तो अगर ये इंटेग्रल डाइवर्जेंट है तो 1 to इन्फिनिटी ये भी डाइवर्जेंट ही है, कोई इन्फिनिटी पे इसका फर्क नहीं पड़ने वाला। अगर ये डाइवर्जेंट है, डाइवर्जेंट इज लेस देन इक्वल टू फाइनाइट सम, तो ये फाइनाइट हो नहीं सकता। एक पॉजिटिव नंबर इन्फिनिटी से बड़ा है तो इसका मतलब इट हैज टू बी इन्फिनिटी। और दूसरे वाले में आपने ये जूम किया कि अगर ये फाइनाइट है तो आपके पास ये फाइनाइट है, तो यहाँ से आप इसको पकड़ सकते हो। ये तो जो स्टैंडर्ड मेथड्स ऑफ प्रूविंग है ना।
और सर जब फाइनाइट होगा तो कन्वर्जेंट हो जाएगा, जब इनफाइनाइट होगा एस एन तो वो डाइवर्जेंट हो जाएगा।
यही दोनों हमने बात।
ओके सर,
ठीक है। आई थिंक इतना ज्यादा प्रूफ में नहीं है, इसको थ्योरी में बुक से पढ़ो। जो फाइनल डिस्कशन है उसके बेस पे आई थिंक कि मैं डायरेक्ट क्वेश्चन पे आता हूँ। फिर आपको जो है वीकेंड है आपके पास, जस्ट थिंक कि जो आपके क्वेश्चन कुछ मुझे मिले हैं भाई वो आपको मंडे ट्यूसडे के बाद करेंगे। वीकेंड है आपका 8.4 तक खूब क्वेश्चन करिए, 8.4 30 क्वेश्चन तक। ये खूब डाउट्स लेके आओ आप, संडे तक भेज दो मेरे पास, फिर हम आपको बात करते हैं। अभी मेरे को एक पॉइंट करने दो, एक बड़ा अच्छा रिजल्ट है and I think that result is going to affect our next calculation. So that result is, it is called P test. मैं थोड़ा जल्दी में करूंगा भाई इसको। It is proved in your examples, example 3. So I have only 5 minutes. So this P test is summation 1 by n raised to power p. मैं शुरू से बोल रहा हूँ, मुझे आज तक ये नहीं पता लगा कि summation 1 by n कैसा है और summation 1 by n square क्या है। So now I'm going to get answer of this side. So what is summation 1 by n raised to power p, and p is a positive constant. P is a positive constant. Now I'm going to find answer of this question. Now its solution is an. So n is from 1 to infinity. So our an is 1 by n raised to power p. Now n plus 1, it is always greater than n. 1 by n plus 1, it is always less than 1 by n. Or 1 by n plus 1 raised to power p, it is always going to be less than 1 by n raised to power p. Since p is a, otherwise you can take derivative also. तो इसका मीनिंग ये होगा भाई कि an plus 1 it is going to be less than equal to an. Number 2, this 1 by n raised to power p, it is always greater than equal to 0 since n is greater than 1. And then third, this 1 by if I'm replacing this n by x, so fx is 1 by x raised to power p. So the threat is x equal to 0. So for x greater than 1, this function is continuous. All the 3 conditions are satisfied. So if all the 3 conditions are satisfied, that means we can apply integral test. So we can apply integral test. Now what is integral test? So integral test is, instead of this series, go for one integral. So that integral is 1 to infinity, and then it is 1 by x raised to power p dx. Now what is integration of 1 by x raised to power p? So it is x raised to power minus p plus 1 divided by minus p plus 1, but it is only the case when p is not equal to 1. So that means there will be 2 cases. So I'm taking case number 1. So when p is not equal to 1, because when p is equal to 1, then it is given by log, and then it is 1 to infinity. Now when we are taking limit x to infinity, now you can see it is going to be infinity power minus p plus 1. And this p is given to be a positive constant. So इसमें हम चलते हैं इसमें. So this number x, अगर ये वाला नंबर जो हमारे पास है x जो है, this minus p plus 1, can we say infinity power anything is going to be infinity? X is going to be infinity, but it also depends upon minus p plus 1. So if minus p plus 1, within this case 1, there are again two cases. So if minus p plus 1, it is less than 0. So if this number is negative, so then it becomes infinity power negative. So when infinity power negative is there, so it is 1 by infinity, it is going to be 0. Then this term is defined, and there is no threat to this term at x equal to 1. 1 पे तो डिफाइन ही है, इन्फिनिटी पे प्रॉब्लम है, लेकिन इन्फिनिटी का पावर अगर नेगेटिव आता है तो इवन देन इट इज डिफाइंड. तो इसका मीनिंग ये हुआ, इफ माइनस पी प्लस 1 इज लेस देन 0 और माइनस पी इज लेस देन माइनस 1 और p is greater than 1. So within this case, if p is greater than 1, so then this integral converges to a finite value, or that means this integral is convergent. Now the second case, if this minus p plus 1, so it is greater than 0, minus p plus 1 is greater than 0 or p is less than 1, between 0 to 1, p greater than 0. If p is less than 1, so इस केस में क्या होगा, this term will be positive, x is infinity and infinity power positive, that means it is going to be infinity. So उस केस में क्या होने वाला है, so in that case this integral is I is moving towards infinity value, so that means it is divergent. And the second case is when this p is equal to 1, then integral is 1 by x dx, it is 1 to infinity, it is ln x, so it is 1 to infinity and it is infinity, so it is divergent. Now if you compare, so what the result I have given is, so 1 by n raised to power p, it is convergent if p is greater than equal to 1, and it is divergent if p is less, it is convergent, sorry, 1 by n raised to power p, so it is divergent, so when p is greater than or equal to 1, and it is convergent if p is less. So I will start from this result in your next lecture. So it is solved in example number 3 on page number 660. So please try to solve 8.4 exercise, at least 1 to 10 or 15 questions जितने भी कर सकते हैं, ठीक है. So I will start from here in next lecture. So I'm ending this.
तो थोड़ा ऊपर कर दीजिएगा प्लीज.
थोड़ा सा ऊपर कर दो.
यार आपका ना ये नेक्स्ट लेक्चर वेस्ट होएगा मेरे इस जूम सॉम पे ना.
बस 1 मिनट.
1 बजे खत्म हो गया.
ये बुक में सोल्ड है आपका.
फिर 1 मिनट कर दो.
सर ऊपर कर दो.
लो.
ऊपर कर दो थोड़ा.
अरे कब तक अपलोड कर दोगे आज आप पहले मुझको?
ये पीडीएफ तो कर दूंगा, वीडियो को देखता हूँ.
सर आपने लास्ट स्टेटमेंट गलत नहीं लिख दी शायद.
अब तो ठीक कर दिया यार.
सर कन्वर्जेंट इफ p इज ग्रेटर देन 1 आएगा ना.
हाँ ठीक है यार, वो उसमें हो रहा है, डाइवर्जेंट आ रहा है आपके पास, समेशन 1 by n raised to power p, ठीक है.
थोड़ा ऊपर कर दो.
समेशन 1 by n raised to power p, वो पहले ठीक लिखा था. So it is convergent for n, for p greater than 1, and it is divergent for p less than equal to 1. ये आपकी स्टेटमेंट.
यस.
इसको मैच कर लेना ऊपर एक बार, मैं अगर कोई डाउट हो तो मैं नेक्स्ट टाइम से फिर दोबारा डिस्कस करूंगा.
ओके सर.
इसको क्लोज कर दो.
थैंक यू सर.
ठीक है भाई.
थैंक यू सर.
थैंक यू सर.
थैंक यू सर.
सर एक बार ऊपर करो ना.
बेटा प्लीज, अब तो आपका नेक्स्ट लेक्चर वेस्ट होगा ना.
सर
हाँ जी सर. ओके थैंक यू सर. बाय बाय सर.
बाय.
थैंक यू सर.
थैंक यू सर.
सर 1 o'clock तक है ना क्लास?
सर आपकी 1 बजे तक क्लास.
1 बजे तक है सर.
अरे प्लीज प्लीज, मुझे पता नहीं था यार.
सर 1 बजे तक है.
सर लीव कर गए.
मैं
स्टूडेंट लीव कर गए.
सब लोग लीव कर गए.
बता दिया यार, ये ना टाइम का ना कुछ 12:50 और पता नहीं 1:50.
सर 1 o'clock 50 minutes की हो गई ना. 12:10 to 1 o'clock.
तो अभी तो मेरे पास टाइम है फिर बोल.
हाँ सर चलते हैं आगे.
नहीं
सर वो बच्चे लीव कर गए सर.
बच्चे लीव कर गए सर.
चलो जो बच्चे नहीं लीव किए थोड़ा वो सुन लो क्या बताना चाह रहा हूँ मैं, कि समेशन 1 by n raised to power p, so इसका जो बिहेवियर है that is being judged by integral 1 by x raised to power p dx if p is from 1 to infinity, p is from 1 to infinity.
सर आपकी स्क्रीन नहीं शेयर हो रही.
अब ठीक है.
यस सर.
So convergence of this series, it is being judged by 1 raised to power x raised to power p dx integral. और जो हमें रिजल्ट मिला वो ये मिला है कि when p is greater than 1, ठीक है, तब जो आपके पास जो 1 by x raised to power p है, this integral becomes finite. So that means this integral is convergent and hence this series is convergent. For p equal to 1, कुछ नहीं हुआ, log n मिला, ये divergent. And for p greater than 1, so it is also that. So that means अगर आपके पास summation 1 by n series है, summation 1 by n square series है, summation 1 by n raised to power 1 by 2 है, summation 1 by n raised to power 3 by 2 है. So now you are at this position that you can discuss its convergence or divergence. Yes, what is the behavior of summation 1 by n by p test? It is convergent or divergent?
डाइवर्जेंट.
डाइवर्जेंट.
अब
सर एक्चुअली सर उधर साइन आपने गलत डाल दिया सर. डाइवर्जेंट p लेस देन 1
yes,
1
है.
सर आपने
सर
साइन
इधर
डाइवर्जेंट में p less than 1
हाँ,
और डाइवर्जेंट.
ठीक.
यस.
यहाँ पे ये ठीक है, यहाँ पे कुछ और बोलोगे. So summation 1 by n. So what is summation 1 by n? So it is divergent.
डाइवर्जेंट.
So summation 1 by n square.
सर कन्वर्जेंट.
कन्वर्जेंट.
1 by n raised to power 1 by 2.
डाइवर्जेंट.
डाइवर्जेंट.
And summation 1 by n raised to power 3 by 2.
Convergent, sir.
कन्वर्जेंट.
So now see the difference. अगर यही पॉइंट हम आपको स्टार्टिंग में बोलते हैं फर्स्ट डे की, हाँ जी summation 1 by n डाइवर्जेंट है, 1 by n square कन्वर्जेंट है, then आंसर वाज कि अगर कन्वर्जेंट तो सम बताओ ना मुझे आप. So what is summation 1 by n square? It is convergent, but can we find its sum using our regular simple analytical methods?
नो सर.
नो सर.
हाँ, जो ठीक है, जो डाइवर्जेंट है, यू कैन अवॉइड दोज क्वेश्चंस कि ठीक है वो तो डाइवर्जेंट है, नहीं आ रहा भाई, नहीं आया. बट इफ इट इज कन्वर्जेंट देन डेफिनेटली देयर दिस सम इज डिफाइंड. सो सम डे विद सम टेक्निक यू कैन फाइंड इट सम. बट अभी तक सिर्फ इतना ही हुआ कि यस वी कैन रिप्लेस दिस बाय सम फिक्स क्वांटिटी, और इसका आंसर मिलेगा आपको. यू विल फाइंड सम समेशन 1 by n square, 1 by 1 square, 1 by 2 square. So this in next semester in Fourier series you will find this sum. इसका आंसर मिलेगा आपको pi square by 6 या pi square by 4, ऐसा आंसर वहाँ पे फिक्स है. हाँ, this 1 by n raised to power 3 by 2 it is again difficult to find. ऐसा अब देखो that is the advantage of studying this method. अब आपको इतना तो क्लियर हो गया कि 1 by n raised to power 5 by 2, 1 by n raised to power 100, all these are convergent. अब इनके सम क्या होंगे, ये हिस्ट्री है, मिस्ट्री, ये हमारे पास इतने वो नहीं.
माइक कर दो है नहीं हमारे पे.
चलो ठीक है भाई, ठीक है, चलो मैं लीव करता हूँ, काफी चले गए इसमें. कल इसे स्टार्ट करेंगे हम. सो फ्रॉम क्वेश्चन
अगर बस में जाना हुआ.
टाटा.
कर दीजिएगा.
थैंक यू सर.
ओके.